So a moving truck accidentally starts to drive while its loading ramp is extended with a box of dinnerware resting on the ramp. The box has a mass of 20 kilograms. The ramp makes an angle of 20 degrees with the horizontal, and the coefficient of static friction between the box and the ramp is 0.6. Determine the fastest the truck can accelerate before disaster occurs. So here is the bed of the truck. Okay, this is like that, right? I don't know how to draw the truck. That's at 20 degrees theta. And there's the box here. And the truck accelerates this way. We want to see what is the acceleration, maximum acceleration that this can stay put, right? Compared to this, it doesn't slip. All right, so how many forces are acting on the crate?
4.
1?
I said 4.
4.
Yeah.
What are those?
Normal, weight,
Normal force, yeah.
weight, friction, static friction.
Which direction is friction?
Upwards.
Up the ramp, right? It's parallel to the surface, and it is in the opposite direction of the tendency of the object to move. It has tendency to move down, so it is up here. What else? There's nothing else. There's just one surface that has maximum 2 forces, normal and friction, and nothing else, right? Alright, so draw free body diagram. How would you take free body diagram? Horizontal, vertical, because of the acceleration. Yeah, that makes sense. Alright, acceleration is horizontal, so it's better to take horizontal direction as x direction and y direction vertical. And alright, so normal force is at an angle, which makes the same angle theta with the y-axis, right? And the friction makes the same angle with the x direction, fx. Right? The same angle here. And this is the weight. This is mg. Normal force. And so this is the situation. All right. So let's apply Newton's law. See what we get. I don't know what to get. I haven't done this before. So this is theta. So what are the y components? Sum of Fy equal to MAY. And AY is 0, so we get 0. Right? So we get what?
And cosine theta.
Yes, and cosine theta. Very good.
Plus Fs sine theta.
Fs sine theta plus minus W minus mg equal to 0, so it becomes equal to mg, right?
Yeah.
So this is one equation. And Fs and n are related, right? And that is also related to acceleration. So we don't know n, we don't know Fs. We cannot do anything. If you want, we can write Fs, okay, a critical situation, Fs is Fs max, when it's about to slide, then you can write it as mu s times normal force. And then that gives you the normal force, right? That basically gives you normal force. But let's write down the horizontal component. Sum of Fx equal to ma. Sum of Fx means what? Is Fs
posterior
cosine theta
minus sine
minus n sine.
theta.
Very good. Equal to
Posterior
mn, right? So you see, fs and n are both appearing in both equations. So we say that for the critical value of A, fs should be as at its maximum, right? So we put A max, and this becomes fs max, and we write that equal to mu s times normal force, right? So we get mu s times normal force times cosine theta minus normal force sine theta equal to m A max. But we don't know normal force, we use this equation. So this goes to that one, becomes a new equation. And then this one becomes also n cosine theta plus mu s n sine theta equal to mg. This is another equation. So how do we get rid of n to find A max? Divide them, yes. You see, all of these terms have n. So if you divide them, you get A max. And A max over G, m also cancels. A max over G becomes what? N cancels, so I don't write n. Mu s minus theta, minus sine theta, mu s minus sine theta. Mu s cosine, sorry. Mu s cosine theta minus sine theta divided by cosine theta plus mu s sine theta. Can you write it in a pretty way? If you divide both numerator and denominator by cosine, what do you get? Mu s minus tan theta divided by 1 plus mu s tan theta. Do you see the same equation?
Yeah.
What is that? So A max is equal to G times, if you say mu s is tan of theta s, yeah, tan of theta s minus tan of theta divided by 1 plus tan of theta is tan of theta. Becomes tan of theta s minus theta. There's negative between them. So it becomes tan of theta s minus theta. Isn't that pretty? This is the first time I do a problem like this. I never saw this problem before. So, what does that mean? Means that if theta is already equal to theta, A max is 0, right? It is already on the verge of slipping, so if you have a little bit of acceleration, it will slip, right? If theta s is equal to theta, means that experiment that I did, right? If you have this, I need something probably. You see here, if you keep increasing the angle until it is on the verge of moving. So that is already on the verge of moving. If you accelerate, of course it will move. Any small acceleration will move it, right? So A max becomes 0. But if this is the smaller, it requires some acceleration to make it start. All right? And now you can now plug in the numbers to get the acceleration. So G, now what is mu s? Mu s is 0.6, right? What is theta s? Tan inverse of 0.6. Mu s is tan inverse of 0.6. What is that?
80.96.
Sorry?
30.96.
30? Oh, 30.9. Sorry. Yeah. Mu s. No, not mu s. Sorry. Theta s. Theta s is tan inverse of. Theta s is 30.96, almost 31 degrees, right? And then theta is what? Theta is 20, right? So A max will be 9.8 times tangent of theta f, which is 30.96 minus 20. So that's about 10.96, right? 10 of 10. Which is about, I don't know.
1.89.
Sorry?
1.89.
1.89, yes. So maximum acceleration that the truck can have without this slipping is 1.89 meters per second squared. All right? There are plenty of night 3 problems I gathered. I thought we could go through more tonight, but we couldn't get through that. This is 1.